Electron affinity is our next periodic trend, and we can define electron affinity as the amount of energy associated with the gain of an electron by a gaseous atom. So this is kind of the reverse of ionization energy, where ionization energy, it's the amount of energy required to remove the electron. Here it's, I take a particular atom, such as fluorine, and I'm going to give it an electron. Does the fluorine want the electron, or does the fluorine not want the electron? In this case, fluorine has 7 valence electrons, so it would really, really like to have another electron. The electron affinity associated with this, or the energy associated with this, is negative 328 kilojoules per mole. And remember that the more negative the energy, the more stable. So if we have a very negative electron affinity, that means that this is a really good situation. It's going to be very, very stable. So the higher the negative value, the higher the electron affinity. And our general trend for electron affinity, it's going to decrease as we go down a group in the periodic table, and it's going to increase as we move across a period. And again, I put a little star next to the increase because this is not a linear trend. So we can analyze this trend again for the elements in the second period of the periodic table. So if we look at our electron affinity versus group number, we give an electron to lithium, it will take one, right? Beryllium doesn't want an electron as much, so it's going to drop off. Boron will continue to increase and go up with carbon. With nitrogen, it has a half-filled p orbital, so we're going to see a dip in the stability when we give an electron to nitrogen. Then oxygen and fluorine are going to be pretty high because they really want an electron. And remember, each of these species is trying to achieve an octet, so it would like to get 8 electrons. To get 8 electrons, we need to take at least 1. So another thing with the noble gases here is that the noble gases don't want electrons at all. So when we typically represent these, they're going to be off the charts in the opposite direction than they were for ionization energy. So for electron affinity, you need to think of, I have a particular atom, I'm going to give it an electron. Will this want to be stabilized, or will it want to be destabilized? And the higher the negative value, the higher the electron affinity. For example, this would be negative 328 kilojoules per mole on the scale, but we represent that as the largest electron affinity. Okay? For neon, the electron affinity is going to be much greater than 0 because when we give an electron to neon, it does not want it, and it's going to become more unstable and not become stabilized. So these are the general trends that you need to look at when we discuss electron affinity.